Okay, so coleslaw. Yesterday we were working on sine law. The angry robot closer. I like that. Okay, so with sine law yesterday, what were we looking for with our triangles? Two loops. So if we look at this triangle that's shown here, can we make two loops? Yes. Okay, we've got an angle. Do we know the side? No. No. Do we have another angle and side anywhere? No. No, we can't make any of these loops. We've got too many unknowns. So with our two loops, we only want one unknown and everything else known in there. Does that make sense? So two loops isn't working for this one. Okay. So that's the problem. Insert cosine law or cos law. Another method that they're showing us in example 1 is we could use our right angle triangle. We could create a right angle triangle and perhaps solve for this side to get our BD length by subtracting 3 from it. We could solve this side and then use Pythagorean theorem to get this side. Seems like a lot of work. So it is possible to use our SOHCAHTOA to solve this. I'm not going to go through it though. Is that okay? We'll use the better law. So there's two forms of cosine law. There is this form. And we label the sides of our triangle the same way that we were doing yesterday. So right across from angle A would be side A. Right across from angle B is side B. And across from angle C is side C. So same way we label our triangle. Just like with our sine law, we could use any part of it to solve for any letter. Same thing here. What we do want is that this side length that we're solving for matches the angle here. So if we're solving for side A, we're going to be using angle A in our cos. And then the B's and the C's will be the other sides. Does that kind of make sense? Not making sense? So for instance, if we wanted to solve for side C, we would have A squared plus B squared minus 2 AB cos C.
And how would you explain that? You said if you were solving for A and
so here we're solving for C.
Yeah.
Our side matches our angle. And then the other two sides are these parts in here. So we could rewrite this law to solve for side B as well. So we would need a cos angle B here. So those are matching. What would our other parts be? The other two sides, which are A and C. So A squared plus C squared minus 2AC. So we could rewrite this law just like with our sine law for whatever side we're trying to solve for. Kind of makes sense? Maybe it'll make more sense when we do a couple of examples. Ava, did that help a bit? Yeah, okay. So our book goes through the proof of cosine law, so basically the derivation of it. I'm going to skip that. If you're interested in where this law comes from, you could read this, and if you have any questions, we can go through it. You want to let me scroll back up? But we're going to skip the derivation and go right to using this law. Sound good? Take your silence as an affirmative. Good? Okay. Okay, so when do we use this form? Our little policeman tells us that we're going to use this version of cosine law. Can be used in any triangle if the given side length of two sides consists of two sides and the angle. So how we remember that is sats. If we have a side, an angle, and a side, we are using this form of cosine law. We have sats, we're going to use this form of cosine law. Does that make sense? Side, angle, side.
Is there a tan law?
There's not a tan law, but there's a second version of cosine law. Our cosine law and our sine law and SOHCAHTOA are all we need to solve our triangles. That's all we need. We don't need tan law. Are we ready? So another way to think of it is we're looking for the side opposite the angle. So we're shooting an arrow across, and we've got the two other sides. It makes this crazy fork. So we could either look for two loops, then that would be sine law. If we can make a fork, we're using cosine law.
That's a very bent fork.
It's a very bent fork. They're usually quite deformed. Maybe I'll draw it a bit better. Critics.
Fork in the road. That would make sense more than I would have wrote fork.
Is that a little more forky? Yeah, like a trident. So we're eating our coleslaw, or coleslaw,
With a trident?
with a trident.
I don't eat coleslaw so much.
At any rate, your choice. So fork, you like drawing a fork, or if you're able to recognize side, angle, side, or perhaps you're looking for loops and they're just not arriving, and we're looking for a side length, we're using this form of coleslaw. Is that okay?
Too wordy. You're saying coleslaw.
I know, I might be. I might be saying coleslaw, or I might be saying coleslaw. It's hard to say. Okay, so let's read this question. I think I rambled on ineffectively long enough. So consider our triangle ABC. That was the one they showed us on the first page. We've got angle A as shown of 36 degrees. Length A to B is 3 centimeters. They've drawn that for us. And length A to C is 6 centimeters. They've also drawn that for us. Determine the length of B to C.
Wait, Miss Russell.
So we're looking for this one. Yes, Grant.
Like, you know how it's like A squared equals B squared plus C squared, whatever?
Mm-hmm.
To find the lengths, can you still do the thing with like sine law where you go from like the angle to that length? Like, cause you know how it's A to B, but like, how do you know what side is A and what side is B and what side is C?
So we practiced labeling our sides of our triangle yesterday. Remember, right across from the
Yeah, that's
angle,
what I meant, like using the sine thing.
we're shooting it with an arrow. Right across from angle B
Is B.
is little b, and right across from angle C would be little c. Does that answer your question, Brandon?
Yeah.
Yeah, okay. So we're still labeling the same way. So we've labeled them A, B, and C. We've already talked about how we can't make two loops with this problem. So it's impossible to solve using sine law, so we're going to use cos law. So we're looking for A. So we're going to start A squared over here. The thing that should match over here should be the cos of what? Angle A. And we're filling it in with the other sides, which is B squared plus C squared minus 2BC. So far, so good?
Well, where did you get, oh, because you're trying to find A, so you knew it had to be BC in your mind?
Yeah, because we have those. So our B and our C, we know those. So we can fill in those numbers. Our angle A, we know that as well. Our sine law has our cos law has the form where the angle and the side that we're looking for are matching. Taylor.
I might have it written down wrong, but
you're looking for side B, so it has to be negative 2AB or negative 2AC.
So we're looking for side B.
Yeah.
We're looking for side
yeah.
B where we don't know it. So if we have a unknown B in here, then we've got two unknowns. So I think you guys will be okay for filling this in once we do it a couple times. Does that make sense?
Yeah, I just wrote it down.
Okay. Okay, so now we can put our values in. Are we ready? So we know B is 6, so we're doing 6 squared. C is 3, so plus 3 squared minus 2 times 6 times 3 times the cos of 36 degrees. Do we want to baby step this in our calculator or all in one go?
All in one.
All in one? Okay. So notice that this is what a squared equals. So what do we need to do?
Square root everything.
Square root everything.
Could you just like get the answer of square root everything?
You can. So that's what I mean by baby stepping it. So you could get the answer and then square root it at the end. What's your preference, kids?
At the end.
At the end? Okay. Alright, so we're entering this in our calculators. I need to make sure I'm in degrees. So 6 squared plus 3 squared minus 2 times 6 times 3. Oops, that's not a 3. And then the cos of 36. So a squared is 15.875. A squared is 16.875.
Wait, it's 15.
Oh, 15, thank you. And now to get A, we are going to square root.
That's 33.
Brandon already worked it out for us. 3.98.
98. Or now they up to the nearest count. It's 4.
4.0 centimeters. Perfect. So does that make sense?
That's a stretch.
Sarah's not so sure.
Hold on, why did you, when you subtracted your 2 and then your 6 grade plus 36, are you always subtracting it or is it just this one?
It's always subtracting. So we're always going to write the formula in the same manner.
Wait, Miss Russell.
Yes.
Just say it the different letters, right? And you know how you have like the different say like A is that and B is that. So you know how you subtract like A to C if you're finding B. How do you know what one to put first? The bigger number. Well, because like
It doesn't really matter.
3 minus 6.
Yeah, it doesn't matter. We could have written 3 squared plus 6 squared minus 2 times 3 times 6.
Oh, okay.
So write these. Doesn't matter the order.
Okay.
So far, so good. Okay, so next problem. Sarah? Alright, find the length to the nearest tenth of a centimeter, the third side of triangle PQR. So they've given us our triangle drawing for us. They're telling us if Q to P, so Q to P is 1.7 centimeters. Q to R is 3.1 centimeters, and angle PQR, so that'll be the middle angle of Q, is 110. two ways of thinking about this. We're looking for the third side. You could either draw your, we're calling it a trident, or you could recognize that we have SAS, side, angle, side, something that this class has a lot of. SAS, get it? Get what I did there? And that's going to tell you to use cosine law, version 1.0. Because it's not a right angle triangle. So Pythagorean theorem only works for a right angle triangle. So good thought. It doesn't work because we're obtuse. So far so good? Okay, so let's label our sides. Side across from big Q would be little q. Side across from big R would be little r. Side across from big P would be little p. Alright, let's get Sarah to help us write out our cosine law with different letters. It's going to be crazy. Yeah.
Q squared
Equals.
is P squared plus R squared. Take away 2PR cos Q.
Nice. Nicely done. So now that we've got that, we can put some numbers in. So Q squared is equal to P squared, which is 3.1, plus R squared, which is 1.7 squared, minus 2 times 3.1 times 1.7 times the cos of 110 degrees. So I'll get you children to enter this in your calculators this time. Are you baby stepping it, or are you going to square root the result? Sydney, do you want to use my calculator?
This is what I missed.
You guys get 16.10.
So is that your squared result, Sarah, or is that the square rooted result?
I know.
That would have been the square.
4.01. Yep.
The square root result is 4.013.
Nice. And they say to the nearest tenth, so 4.0 centimeters.
Which happens to be exactly the same as the other one.
Yeah, same as the other one.
Is that a coincidence, or will the answer always be 4.0?
That's, you know, what's funny is I got that same question last year, and I think even the year before.
Well,
It would make it a whole lot easier if the answer was just 4.0
And then we
all the
wouldn't
time.
have to do these calculations every time. But no, the answer will not be 4.0 every time.
That's sad.
But even if the answer was, we'd still have to show your work.
We'd still have to show our work. That's true. Okay, so our next problem is very much the same, but now we're drawing our own triangle. So they're giving us some cities, and they are cleverly labeled to start with a B, an A, and a C. And we're looking for the distance between the B and the C city. So we've got Bellevue is 30 kilometers north, so I'll label it B. 30 kilometers north of Ayer, I don't know how to say that one. Your guess is as good as mine. So this length is 30 kilometers. And then Churchville is 18 kilometers northwest. So never eat shredded wheat, northwest. So C somewhere over here. And it is 18 kilometers northwest of here. So this side will be 18.
We have an issue.
We have an issue.
We need an angle.
Northwest. So if we're directly northwest,
Is that 45?
if we're directly northwest, that would make
45.
this angle 45.
So the side that's 18 and the side that's 30 are the same length.
Yeah, my picture's not to scale. So I'll put a little disclaimer here. Drawing not to scale.
Just making sure I'm not missing something before.
So far so good? So we've got SAS, side angle side, or if you like drawing the ugly shaped trident, we are looking for this distance right across from our angle, and we've got our two other sides. So SAS means we are using cosine law. So let's label right across from big A, we are looking for little a. Across from big C is little c. Across from big B is little b.
We have to learn both cosine laws, don't we?
So next one will be the other form of our cosine law.
They should name it something else.
But they both have cosine.
Yes, they should name it something else.
And it's all the same stuff, just rearranged. So it technically is the same law,
that
just with some algebra.
that's
They're
going to have
saving
3
you.
sides and no angles.
They're saving you some algebra. They're pretty nice.
Oh,
Am I
it's all
making?
in?
Yeah.
Oh.
They just rearranged it. So it's the same equation. So it could have the same name. All right, let's get Sam. Can you give us our equation? What will it look like?
A squared, so like, just the equation or the numbers?
Nope, just with the letters.
Well, A squared equals B squared plus C squared. Equals ABC.
Nice. Okay, so we can plug our numbers in. B is 18, we're squaring it. C is 30, and we're squaring it. And we're multiplying it 2 by 18. Oh, sorry, this should be a minus. Cos of 45. So I'll let you children crunch those numbers for me again. Okay, so Damien has A.
20.455. 21.455.
So we've got 2 people that found A. 3 people? 4? Did this work out okay for everyone? Hopefully. So it says to the nearest kilometer, so A would be 21 kilometers.
I say we finish this lesson right now.
We're not quite finished.
Well, like,
So we're going to look at the alternative form of cosine law. It's the same thing, just rearranged. Just rearranged too. So we get both forms on our data sheet, which is nice. So with this one, we know 3 sides. So we know side, 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 or you could make the snake sound. So if you know all the sides, you're going to use this version right here. So all the sides are known, no angles are known. We can find an angle. Remember, we've got 3 different versions, or potentially more if we use different letters. So the same things need to match. This angle needs to match the minus a squared term, just like our other one. So far, so good. So to warm us up, they're having us complete the following for the triangle ABC. So if we're looking for angle B, what would the rest of our formula look like? If we were looking for angle C, what would the rest of the formula look like?
B squared.
I'll do
plus
B
A
for you
squared.
guys, and you guys can do cosine. Yes. So yeah. So if we're looking for angle B, we'll have A squared plus C squared minus B squared over 2AC. So we are making sure that these are the matching ones. Does that make sense? You guys try it for cosine.
So this one, right, is cos B, A squared plus C squared minus B squared and 2AC. So then, am I gonna do it? Last time I did this in my calculator, will I get
Yes.
also I go also?
Yeah. That's the question.
We're supposed to do it in the second one.
All right. How'd this go? Good. Michaela, what'd you get?
A squared plus B squared minus C squared over 2.
So A squared plus B squared minus C squared over 2AB. Awesome. Everyone else get that? Okay, so let's do an actual problem with this. So here they are saying determine the largest angle of triangle ABC if little a is 14.7, little b is 8.9, and little c is 12.6. So where will our largest angle be? Let's think about this.
Along the smallest line.
Getting there.
Along the largest one.
Not quite, not in between the two longest lines.
In between the two smallest lines.
In between the two smallest lines, or another way of saying that would be
I don't know.
directly across from the
Hypotenuse. Longest line.
The longest
That's what I'm
line.
trying to say,
Yeah,
though.
the longest line. Perfect. So we are looking for angle A then, because this is our longest side. So I'll attempt to draw this to scale. So we'll say that's 14.7. There's my A. So let's make it a little extra long. My C should be shorter. 12.6. Let's squish this a little more. Our B is 8.9.
Oh, crap.
Oh, I
It's like
see.
a little A, so angle A.
It's not
So it's not a right angle triangle. So it's not a hypotenuse.
There's no hypotenuse.
There's no hypotenuse in this triangle anywhere.
Only right
Okay,
Just the longest line.
If it's an equilateral triangle and you split, can you get two hypotenuse, or are they not called hypotenuse? Because
There'll be hypotenuse then.
Whoa.
Okay, so think about this. If here is my angle's pretty small. Look at this side length between my hands. Pretty small. As my side length between my hands gets bigger, what happens to the angle I'm making with my arms? It's getting bigger. Does that make sense why we're looking for this angle here? It's right across from the biggest side. So hopefully that makes sense.
Determine the largest angle.
Yeah, determine the largest angle. So we're looking for cosine. We're looking for cosine.
But aren't we just trying to determine the angle B?
No, still no. We're determining the largest angle. So I've just explained that the largest angle would be directly across from
It doesn't let you
the
put it in your
largest
calculator.
side.
If this thing does not let you put it in your calculator.
It does, Brandon. We'll put it in together. Okay, so we are going to use this form. Cos A equals
B squared plus C squared minus A squared over 2BC.
Squared minus a squared
That was a question, by the way.
over 2bc. Perfect. So children, are we wanting to baby step this or all in one go in our
All in one
calculator?
go. Let's send it.
Okay, so if we are all in one go and we want to find the angle, and it's cos angle A, Sarah, how would we find just angle A?
Negative.
That's the answer.
Yeah, what's it? Inverse cos. So we're going to do inverse cos b squared plus c squared minus a squared over 2bc. All right, so 8.9
It's wet for me.
squared plus 12.6 squared minus 14.7 squared all over 2 times 8.9 times 12.6.
Hey, Mr. Austin,
Are we ready?
I have a question.
Brandon, brackets are important, so listen up.
I know. I'm just asking. Why couldn't we just do like where it's cos A equals da da da, and write the formula, and then go second cos, the
I
inverse
do
cos, then
accept
go
it
second
and it
also.
won't let me.
Yeah, so you're messing up with brackets here. Okay, so let's look at what will need to be in brackets.
We need the denominator of brackets.
We
by
need the
itself.
denominator in brackets.
The rest of it doesn't matter.
The rest of it does matter. We will need the numerator in brackets, because otherwise order of operations will take this last 14.7 squared and divide it by the denominator here. Then it'll add 8.9 squared and 12.6 squared. So brackets in the numerator, brackets in the denominator, and brackets around the whole thing when it's in cos. So we're going to have to be pretty smart with our brackets. So we are doing inverse cos. We're writing a second bracket right away.
What happens if you don't do that?
Then you're not going to get the right answer. You're going to get an error, and then you're going to be like, Miss Russell, it's not working.
Yeah, well,
Just like you were doing. So 8.9 squared plus 12.6 squared minus 14.7 squared, closing that bracket, then dividing it by bracket.
You said 44, not 14.
Oops. Then we're dividing it by 2 times 8.9 times 12.6, close bracket, and final close bracket.
Press the enter.
it's not even 4 degrees. I'm actually going to kill myself.
I was really confused for a minute. I got 40.
So you should get 84.4 degrees.
Can we be done this lesson?
So far, so good, ladies and gents.
Miss Russell, I got a different answer, but I wrote the same thing.
Okay, well, are you in radians?
No. I'm in the right thingy. I'm in degrees.
Yeah.
Well, I will stop this.